Today we're going to continue with 4.1 solving system of equations in two variables, but today we're going to talk about the third method, which is elimination. The idea of elimination is, just like the word says, is to eliminate a variable. And what that does is it brings our equations down from two variables down to one, which is something we know how to solve. When you start elimination, one thing you want to do is you want to make sure everything lines up. Our x's line up, our y's line up, and also the equal signs and the constants. So everything kind of matches down the line, which in this case it does. Now in other examples, we'll see it will not match up and we'll rearrange it. What elimination does is it uses addition and subtraction to cancel out variables. And if needed, multiplication and then addition and subtraction. So what you're going to do is you're going to look at your variables. You're going to look at your x's, you're going to look at your y's, and you're going to first ask yourself, does anything cancel out? In this case, the y's do. If we were to add the equations together, 3x plus 4x equals 7x, and if you do negative y plus y, those cancel out. And then we add the constants, which is 7. From here, this gives us an equation just with one variable. So we'll divide by 7, and we'll get 1. Once we get a solution to one of the variables, what we can do is we can take this and we can choose to plug it into one of the top equations. It doesn't matter which one. So I'll do 3 times 1 minus y equals 1. So 3 minus y equals 1. I'll subtract the 3 and get negative 2. Y equals 2, so my solution is 1, 2. Now you can do a quick check by plugging into the other ones. 4 times 1 is 4, plus 2, that gives me 6, so it worked out. If we take a look at number 2, and we're going to use the same process of elimination, you'll notice that things do not match up. Although the x's do, you'll notice that the y's do not. So what we're going to do is we're going to take a minute and we're going to rearrange them. I think the easiest way is to put both of them into standard form. Makes it a little bit more consistent. So I'm going to bring the 4y over to the left. So now if we look, everything matches up. Now the next thing I'm going to do is I'm going to take a quick look at how they pair up. I have 2x and 3x and negative 5 and negative 4. If we look at those and if we try to add them together, I would get 5x minus 9y. And you'll notice nothing cancels, which is pretty much the goal. So now we're going to have to think of a different strategy. From this point, it's really up to you of whether you want to cross out the x's or the y's, but usually you want to take a look at them and look at the numbers, see which is more reasonable. Sometimes it's a toss-up. What I'm going to do is I'm going to focus in on the x's. I have 2 x's in the top and 3 x's in the bottom. One doesn't go into the other, so what I'm going to do is I'm going to think about what the LCD is. And the LCD is 6. And so what I'm going to do is I'm going to multiply the top one by 3 and the bottom one by 2. And what that does is 2 times 3 is 6 and 3 times 2 is 6. That gives me the same number. Since I'm changing this number, I'm going to multiply throughout the entire equation to make sure that the equation doesn't change. So now this is going to become 6x minus 15y equals 18. And then this is going to become 6x minus 8y equals 18. Now, if I look at my x's, they are the same. And if I were to add them together, I would get 12x, which doesn't quite help us. So I can do one of two things. I can either subtract the entire quantity and make sure I subtract the x's, subtract the y's, subtract the 18s. Or, and this is what I would choose to do, is I'm going to go back and instead of multiplying by 2, I'm going to multiply by negative 2 and change all the signs. That way I don't have to worry about missing any negatives. And then I'll go back and add. The 6's cancel out. This becomes negative 7y. and then this will be 0. Divide by -7, y equals 0. Now I have one of the variables. I'm going to take it, I'm going to plug it back in, doesn't matter where, and I'm going to solve. So 3x equals 9 plus 4y, but we know y is 0. So then I get 3x equals 9, x equals 3, and I have my solution of 3, 0. Again, we can plug it back in to check. 2 times 3 is 6, minus 0 is 6, and that works out. The last example we're going to do is x over 3 plus 2y equals -1. And the next equation is x plus 6y equals 2. Now you'll notice the x, the y's, and constants line up, but as we talked about in the last class, sometimes it's either easier to get rid of the fraction right away. So I'm going to multiply the top one by 3. I'm going to get x plus 6y equals -3. And then down here, I'm going to get x plus 6y equals 2. Now, if we take a look at it, we notice the x's match up. This is a 1x and a 1x. Now, what I'm going to do is I'm going to subtract the entire quantity. So x minus x cancels out. 6y minus 6y also cancels out. -3 minus 2 is -5. And what ends up happening is we end up getting all our variables canceling out. Think about what this would mean and what it meant in the other equations we worked with. This means no solution. And again, the vocab that we talked about was inconsistent. So if there's a variable, if the variables cancel out and this produces a false result, so 0 does not equal -5, it's going to be no solution. Now let's say when all the variables canceled out, you got 0 plus 0 equals 0. This would be a true solution. And if it's true, in past equations we said all real numbers, but we talked about how systems are different and how it would be infinitely many. And how we wrote that is we wrote that with builder set notation, x and y such that x plus 6y equals 2. So again, if the results cancel out and we get a false solution, it's no solution. And if it's true, we get infinitely many.